Good morning, students. Now, we have started the rotational motion, system of particles and rotational motion in our last class. You all remember, you might have seen the whole video lecture also. We are continuing together today. In continuation in today's discussion rather, we can say, suppose let us consider the n number of particles in a system. Try to follow me. If n number of particles are there in a system, then what is the how the position vector for the center of mass will be indicated? The position vector for the center of mass RCM vector is equal to, we have discussed, m1r1 vector plus m2r2 vector and so on up to mnrn vector divided by m1 plus m2 and so on up to mn. It's a derived equation in the last class. It's not a new thing, it's a derived equation. In the last class we have already derived it. Now, after that, in the next step I can simply write it m1r1 vector plus m2r2 vector and so on up to mnrn vector divided by capital M. I am not writing so many terms, I am simply writing capital M. Capital M is equal to m1 plus m2 plus and so on up to mn. Fine, no problem. I want to find out the velocity of the center of mass. What we shall do? We shall differentiate it. Okay, differentiating with respect to t. We get drCm vector by dt is equal to how much? 1 by m will be out here, d by dt of, I write here m1 r1 vector plus m1 r1 vector plus m2 r2 vector and so on up to mn rn vector. No problem. Then it can be written as 1 by m. Here I write m1 dr1 vector by dt plus m2 dr2 vector by dt plus and so on it goes mn d by dt of rn vector, like this. Just obey the rules of differentiation. Or we can write 1 by m here 1 by m into, here I write this is m1 v1 vector plus m2 v2 vector plus and so on up to mn vn vector. Or finally I can write it in this way also, that v vector cm, this is the velocity of the center of mass, that should be equal to m1 v1 vector plus m2 v2 vector plus and so on mn vn vector divided by, I write in place of m as usual m1 plus m2 plus and so on up to mn, just to show that, see, this equation and this equation both are identical. I want to just mention here, I want to just clarify it that these two equations are identical. अगर तुम्हें सेंटर ऑफ मास निकालना हो, उसका पोजीशन, तो ये फॉर्मूला, और अगर उसका वेलोसिटी निकालना हो तो ये पोजीशन. और जिस तरह से the way I have resolved this into x, y and z coordinates, you can see your last classes notes. Similarly, it can be resolved also in the similar way. Okay, it can be done. Here it is. Now I can write this also, that vcm vector is equal to, can I write it is p1 vector plus p2 vector and so on up to pn vector divided by capital F. Or I write this is here. I can write here the P vector is equal to M into VCM vector. Okay, where P vector is equal to how much? P1 vector plus P2 vector and so on up to Pn vector. This is the total momentum. That means we are getting this expression. You can write down. After this, you can write down. We see that the total linear momentum of a system of particles. We see that the total linear momentum of a system of particles, is equal to the product of the total mass of the system here is equal to the total mass of the system and the velocity of the center of mass. Because I just remind you, center of mass is treated as that point where the whole mass of the system is supposed to be concentrated. So it is equal to total momentum of the system is equal to the mass of the system into the velocity of the center of mass. I hope it's very clear to all of you. Now here I want to discuss that this is regarding momentum. Now let us discuss momentum conservation and center of mass motion. That is the motion of the center of mass. If the center of mass has got the velocity, then it should have a motion of the center of mass. So again, let us consider a system which is consisting of n number of the particles as usual. And what is the total force? Acting on the system? Total force acting on the system. Let us now see F vector is equal to how much? M into ACM vector. Look, simply Newton's second law. According to Newton's second law, what we are getting? The total force acting on the system which is there, that is equal to force into the acceleration of the center of mass. Again, I repeatedly reminding you that center of mass is the point where the whole of the system is supposed to be concentrated. So acceleration किसका लेंगे? Center of mass का acceleration लेंगे. ठीक है? Now I write in absence of any external force. If I consider the absence of any external force, F vector is equal to 0. So M into ACM vector is also equal to 0, which implies ACM vector is equal to 0 as M cannot be equal to 0. Simple mathematics. Either this term will be 0 or this term will be 0, but M cannot be equal to 0. M will have certainly some value. So this is, or we can say dVCM vector by dt equal to 0, which implies VCM vector is a constant, obviously with respect to t. Velocity of the center of mass will remain the same. If no external force acts on a system, very important conclusion we are getting. If no external force acts on a system, then the velocity of the center of mass, not the speed, the velocity of the center of mass will always remain constant. velocity of the center of mass will always remain constant. Alright, this condition also we are getting. In the next class, in the next lecture rather, we will continue with the example of it. How can we give the example of it? That point we are coming. I hope these points are very clear to you.